Hello everybody, this is Todd Frazee and this is the TCOSE-12 assembly tutorial. And this will bring the components of 12A, 12B, and a stud or threaded pin together as an assembly. So if we look at our assignment, you got your 12A model, your 12B model, and then the what's labeled pin. It's really a stud. We are going to attempt to find that on McMaster-Carr, and if we're not able to locate that size, then we'll need to model that as well. Alright, so we're going to go to Fusion 360. You're going to open your data panel. And we're going to save the file as the TCOSE-12 part or subassembly. We will then drag in the 12A. So this is the first number. Alright. And I think I'm going to go ahead and reorientate this more like the image on the drawing. So we'll go 90 degrees in one axis and we'll go ahead and go 90 in the other. Okay, you don't have to. Orientation, what matters is the orientation of this part in relationship to the other one that's joining to it. So we're going to right click on it, the first component, and select ground. That fixes it in space. Now we'll take the 12B part and drag that in to our working space. Okay, we'll drag it off to one side. And we want to orientate the part as it is shown in the drawing, which has these curved slots facing away from the face of the lever component. What this component does is it's a lever. You turn it 90 degrees and it changes the direction of the exhaust and pressure sides to reverse the engine. So we're going to rotate it 90 degrees and we'll say OK. Okay, so we're going to achieve this component assembly using a rigid joint. These two parts are brazed together, but we need to make sure that the slots are clocked as in the drawing. As they're shown right now, this plate is about, it's maybe 90 to 80 degrees off from clocking with the vertical on the tab. So what we're going to do is we're going to go and we're going to make a joint, and we're going to make sure it's a rigid joint, and we're going to select the back cylinder with a snap point in the center of the part. Make sure it says rigid, and then we'll select on the center front face, which will align the center of those two features, rigid. But in order to have the slots align correctly where the top slot is in line with the tab and then it travels to the right, we need to change the angular dimension of the rigid. So we're going to highlight the radial, and we can either simply drag the circle around or we can type in a value here. So its current angle is 90 degrees. If we set that at 0, it then clocks the part as shown on the drawing on page 2. Select OK. So you're now done with that joint. Now all we have to do is put in the pin. Now let's go and look on McMaster-Carr and see if we can find a pin that meets the description. Insert McMaster-Carr. We're going to look for a M5 stud. Okay, so we have metric rods, and we want it threaded on one end. And the overall length of this rod is 24 millimeters, which is really close to an inch, but a little under. So the closest we can get is a 25 millimeter length, which is really close to an inch. And it has a by 8 millimeter thread pitch, 0.8 millimeter thread pitch. So we'll go ahead and go with that component. And we're going to go to product details. And somewhere on the page, you may occur on the right of the drawing, you're going to download the SAT file. So it's save. And here we have our stud. Let's rotate the stud 90 degrees so it faces our component, and we'll select OK. Now remember, our current stud right now is a millimeter longer than design. So what we're going to do is we're going to trim this down to length first. So let's leave this floating in space for now. Okay, so the first thing we're going to do, this pin is a millimeter longer than what our design is. So we're going to trim it down to length. Right click on the pin. We're going to edit its feature. And we're going to create a sketch on the face with the slot on it. And we'll go ahead and draw a circle on the center of the pin. The diameter is somewhat arbitrary. I just noticed that our units are in inch. I'll switch that to metric. Okay, and then we're going to make an extrusion, and we're going to go a distance of 1 millimeter. And I'll make sure you have every zone. Is going to be a -1 millimeter. Okay, and it's going to end up changing it to a cut. And we've now chopped the pin down to the length that our design has. We'll hit Finish Base Feature. And we've got our chop down pin. Now we're not going to worry about the slot on there. That's okay. Now this is going to press in, and so we're going to do a rigid joint. We're going to go capture position, select the center select the cylinder, and our snap point will be the center of the cylinder, and our snap point will be the center of the hole in the lever. Okay, and we get our rigid joint, and we're going to go in the axis of the pin -1 millimeter. As our print says. There we go. We're done. So you're now done with the TCOSE-12 assembly. Should look as shown. Nothing should move independent of itself. It's all in a rigid sub-assembly. Make sure you save. Let's move on to the next one.